We're going to take a look now at synthetic division. It is another way to do long division of polynomials and to deal with just the coefficients and not all the variables. So it's a little bit cleaner. I've written the steps down here. Again, I'm not going to read through each of the steps. Let's go through an example and then you can use this as a reference. So, but the first thing is we're going to, just like before, arrange the polynomial in descending powers. So starting with the biggest exponent and then going down. I didn't mention this in the last video, but any missing terms, so if you go from x cubed to x, that x squared is missing, you put a 0 coefficient in there. And the rest of this, let's look at it in an example. I think that it'll make more sense. So same examples as the long division in the other video that we did. So let's get started. So to start this process, we are going to take in our divisor this positive 9, and we're going to flip the sign. So because it's positive, now it's going to be negative 9. So negative 9. Okay? So that's our divisor. I'm going to write it like that. Now, we don't write all this information down. We just write the coefficients. So there's that invisible 1 for the x squared. So it's 1, 14, 45. So we take the sign there and we flip it and we write down all the coefficients from our terms and write them there. And now we write a line. This first term we just drop down here, always. So this first one we just bring down. Now we multiply. Negative 9 times 1 is negative 9. And we add 14 minus 9 is 5. Now we multiply negative 9 times the 5. Negative 9 times 5 is negative 45, and we add 45 and negative 45 is 0, and we are done. There's no more information, no more columns, so we are done. This is our answer. So notice there's no variables here. So to write our answer with variables, we take the coefficient, and now we go back to our dividend, and we go 1 less in our exponent. So we started with x squared, so that means this is going to be x plus 5, because if to x, it's just a plain constant, and then this 0 is the remainder. So we are done here. There's no remainder. So this is our factor. So again, we would have the factoring x plus 9, x plus 5, which would give us our original polynomial. So when there's this remainder of 0, our polynomial is broken down into just factors, and we can use these factors to solve for the solutions or the roots. Next example here, again, we would have to rewrite this in order. We already did that, so 2x cubed minus 3x squared minus 11x plus 7. So we take our 3, and now let's write our coefficients. 2 minus 3 minus 11 plus 7. Very important. This was minus 3, so we have to change this sign here to be plus 3. And now we make our line. This first term, first coefficient, just gets dropped down, and we start our multiplication. 3 times 2 is 6. Negative 3 plus 6 is 3. 3 times 3 is 9. Negative 11 plus 9 is negative 2. 3 times negative 2 is negative 6. 7 plus negative 6 is 1. And we're done. There's no more columns, no more division to be done. This is our answer. Again, we've stripped away the variables to do the division, so now we have to put them back in. Looking at our dividend, we started with an x cubed. We go down one, x squared. So this would be 2x squared plus 3x minus 2. And now this 1 is the remainder. So I'm just going to write it as the fraction. Again, to repeat, when we do a division, either long division or synthetic division, if we have a remainder, so here we have a remainder, that says we cannot use the result of this division or this x minus 3 to help us find the solutions or the roots. We're going to have to look to find another factor that will give us a 0 remainder when we do the division.